To hear the internet talk about resistant starch, you would think that there's some kind of secret way to convert potatoes and pastas and rice and such into virtually zero-calorie foods. That's what resistant starch does for you. Unfortunately, that's not really the case. Yet. There are scientists trying to engineer foods that would be kind of like that, because it is true that not all dietary starch affects the body in the same exact way, and scientists are still kind of working out the differences. This is a relatively new area of research. It is true that some starch seems to evade digestion in our small intestine. Most starch is digested in the small intestine. It's broken down into simple sugars that absorb right into your bloodstream, but some starch doesn't break down. It passes to the large intestine, where it feeds your gut microbiome instead of spiking your blood sugar. And that's probably a good thing in most modern diets, where we typically get way too much sugar and not nearly enough fiber. Resistant starch is a kind of dietary fiber. Oh, and Brits, by fiber, of course, I mean fiber. Resistant starch is a kind of fibrae. This was proven in the 1980s by Hans Englist and colleagues at the University of Cambridge, who did much of the foundational research here. Quote, "It has for long been believed that starch is completely digested and absorbed in the small intestine of man, but Englist and Cummings here proved otherwise by studying 7 people with ileostomies. That's a hole that a surgeon makes in your belly to empty waste out of your small intestine before it ever even reaches your large intestine, your colon. Surgeons do this in cases where the colon or the rectum doesn't work right, or maybe it was removed surgically. Anyway, by studying the contents of people's ostomy bags relative to what they ate, these brilliant Brits proved that not all starch is broken down and absorbed before it hits the human colon. Most of it is, but not all of it. And some foods seem to have proportionally more resistant starch than others, like about 6% of the starch in the white bread and the cornflakes they fed to their human subjects seem to resist digestion, whereas almost none of the starch in the oats resisted digestion. Oh, so cornflakes are actually healthier than oatmeal. No, absolutely no one said that. Oatmeal still has way more fiber because resistant starch is not the only kind of fiber. The big kind in oats is soluble glucan, which is just a different kind of indigestible polysaccharide. And because it's water soluble, it's particularly good for you because it slows the release of sugar into your bloodstream. Probably the biggest single reason why eating a bunch of junk food makes us feel terrible and eventually get very unhealthy is this. It's because the junk food has lots and lots of sugar, quickly absorbed sugar. You eat a whole bunch of sugar, it is absorbed instantly, almost instantly into your bloodstream, and once there, your body releases insulin to transfer the blood sugar from your blood and into your cells, where it can be used or stored as fat as necessary. The problem with that is that now you have no blood sugar left in your blood, and so it's an hour or two after you ate all of that junk food and you're super hungry all over again because your blood sugar is just completely tanked. So you eat a bunch of junk food again, and so the cycle repeats forever and ever and ever, and it's terrible. Foods rich in soluble fiber gum up our insides, and therefore only a little sugar gets absorbed into our bloodstream at a time. This stabilizes our blood sugar, it stabilizes our hunger, and it makes us less likely to overeat. Resistant starch is not the only kind of fiber, but it is a good kind, and it seems to have properties of both soluble and insoluble fiber, depending in part on the kind of resistant starch we're talking about. Scientists have identified 5 types so far, and this literature review out of China has a handy visualization for each of the 5 types. Resistant starch number 1 is physically inaccessible starch. Starches, of course, are just long chains or branches of sugars, glucose. Your body makes enzymes that break those chains apart into their constituent sugars, and that's how you absorb them. This visualization shows starch granules locked inside strong cell walls. Perhaps this is a fragment of an underdone potato, to quote Charles Dickens. Jacob Marley was actually resistant starch. Anyway, in this scenario, the starch is locked up. It's kept as secure from your digestive enzymes as my communications are kept secure with Surfshark VPN, sponsor of this video. A Surfshark membership is really a whole suite of tools that make your experience of the internet safer and better. If you want private browsing and no ads or malware, turn on clean web. If you want to search privately, use their search tool and get real, unbiased, organic results. And if you need to stay safe on public Wi-Fi or conceal your physical location, well, that's what the virtual private network is for. Surfshark has so many servers all over the world. You just go through one of those and it looks like you are in that location. You can evade censorship this way or just get around geo-restrictions on content. Surfshark has your back across all your different devices, and the best part is how inexpensive it is. Just hit my link in the description, enter my code AdamRagusia at checkout, and you'll get 83% off plus an extra 3 months for free. Just tell them I sent you, Adam Ragusia, all one word, to save 83%. Thank you, Surfshark. So, resistant starch number 1 is physically inaccessible starch. Your digestive enzymes literally cannot reach it in order to break it down. Let's look at RS2. That's what uncooked starch granules look like, kind of like clamshells made up of hundreds of thousands of starch molecules. RS2 is uncooked starch granules. When they're locked up in the clamshell like this, you cannot digest them. Nobody eats raw potatoes because they're disgusting, but we do eat raw bananas, or in this case, plantains. Well, actually, nobody really eats raw plantains, but they do eat them kind of slightly or lightly cooked, and in that event, you probably have some resistant starch 2 in here, and you have lots of it in underripe bananas. Once the banana fully ripens, all the starch converts to sugar. That's why it's sweeter. But if you like slightly green bananas like I do, well then probably some of the sugar in there is still in the form of starch, and since you're eating it raw, it's going to be RS2. Resistant starch number 2 is raw starch, which you cannot digest. RS3 is starch that you cooked, so the granules swelled up with water and they exploded. That's called gelatinization. Gelled starch is normally quite digestible, but in RS3, you have cooled the starch back down again, causing retrogradation, which may look like this, or it might look like this. Basically, the starches link back up with each other as they cool, and they form new crystalline structures. That's why cold leftover takeout rice tastes crunchy, in particular long grain rice like this basmati. Long grain rices have more amylose starch relative to the other kind, which is amylopectin, and amylose is particularly prone to retrogradation, to the point where the little crystals that it forms survive the reheating process. That's why reheated long grain rice always tastes like a little still crunchy or mealy, but that mealiness is resistant starch number 3, and that is good. In this 2015 study out of Indonesia, they fed some people freshly prepared rice, and they fed some other people rice that they reheated out of the fridge, and they measured everybody's blood glucose after the meal. The group that got the reheated rice had slightly lower blood glucose, like here, 5.83 an hour after eating compared to 6.49 in the group that got the fresh rice. Now, your results could, of course, depend on so many factors, like the exact kind of rice you're using and how hot you reheat it, how long it was in the fridge, all that kind of stuff. And the research is actually less clear about how much of that resistant starch number 3 actually survives reheating in other foods, like, say, potatoes. Some studies find very little RS3 in reheated potatoes, but there are situations where we eat cold potatoes, right? As in a potato salad. That means potato salad is actually a health food. No, it doesn't, because only a tiny fraction of the starch is resistant, and all this mayonnaise is a much bigger line item in your calorie budget. That said, processed food manufacturers are absolutely researching ways of creating starchy snacks that are almost entirely resistant starch, and that really would matter. In that case, we're probably going to be talking about RS4, which is starch that has been chemically modified one way or another to be indigestible. The 5th and final type is pretty interesting. It's when amylose starch links up with fatty acids in your food and makes starch-lipid complexes that are indigestible. So many of our favorite foods have a lot of carbs and a lot of fat, and it's pretty tantalizing to think that they could, under the right kind of cooking conditions, cancel each other out, the carbs and the fat. So scientists are studying that possibility a lot because, duh, that would be awesome. Hence the SPUD project. a currently in progress set of experiments happening in the UK where they're going to try making mashed potatoes lots of different ways. Different chilling and reheating methods, different kinds of fat, and they're going to see how all of these different recipes affect people's blood sugar. I hope to report those findings to you when they become available. But until then, don't go thinking that the carbs in your food don't actually matter, because they might be resistant. The actual quantity or proportion of resistant starch in most normal foods is probably just a few percentage points of the total carbs in the food, so it's just not that big of a deal. At least in terms of your calories. But even a small amount of resistant starch could still matter to your health, because when it reaches the bacteria in your gut, they ferment resistant starch into short-chain fatty acids, and these are probably really good for your health for reasons that we'll talk about another day.